Alright, today we're diving into one of the trickiest interview questions in JavaScript, the one that makes even the seasoned developers question their life choices. Okay, so yes, you guessed it right. It's asynchronous JavaScript. Okay, the kind of a question where you stare at the code thinking everything is fine, and then it breaks. And not just breaks, it breaks in a sneakiest way possible, right? So before we actually jump into the interview question, right? So we'll actually understand what happens behind the scenes, okay? How JavaScript works asynchronously, what enables it to do so, and all this stuff. Okay, see, when a language is single-threaded, it can only do one thing at a time, okay? And in case of JavaScript, JavaScript is a single-threaded language, which means that it should be able to do one thing at a time, right? Actually, no. See, JavaScript being a single-threaded language, it can do multitasking. That is kind of similar to how multi-threaded language works. Okay, and what makes it possible is called the event loop. You guys might have heard about this event loop, right? Even this topic comes up a lot in interviews and everything. See, event loop is like a secret weapon for JavaScript. What it does is it can start a task, put it aside, okay, and come back later to check up on the progress. Okay, so this whole thing enables JavaScript to perform multiple functions without blocking the flow. Okay, so this is what event loop is. Okay, this is what enables JavaScript to perform asynchronous task. Okay, and JavaScript uses combination of callbacks, promises, async await, the new one, the async await and everything to handle all this multitasking magic, aka the asynchronous task. Okay, and when you're in an interview, they love to test how well you understand this flow. Okay, but because see, let's face it, writing an async task without fully grasping what's happening under the hood, it's like driving a car without knowing how to brake, right? So today we'll actually dive into one of the code, okay, that I'm going to show you one of the trickiest async interview question that I've actually faced myself. It took me a while to solve it, okay, and it ended up being way simpler than I initially assumed it was. Kind of embarrassed myself actually, but it was actually the trickiest JavaScript interview question. Okay, so let's actually jump into the problem statement. There we go. So we have three files, 123.js, each having three different implementation of asynchronous JavaScript. And on the left side, we have the terminal to actually run the code. Okay, so let's analyze the code here. So at the first line, we have an array with three elements, okay, which is a string, 123 string. Very important to understand it's a string. Okay, and then we have a sleep function, nothing but to simulate the asynchronous process. Okay, so it returns a promise and it has a set timeout, which is set to a timeout as a parameter. By default, it is 1 second. Okay, and we have an expensive stuff function, which does an expensive stuff, nothing but just logging the starting of the function, sleeping for 2 seconds, then multiplying the value, which we get in the parameter, and then ending the stuff, returning the response, okay, or return the result. And then we have another function that does the for each loop. So loop for each, which is nothing but a data dot for each. So it loops through all these elements using a for each loop. Okay, and then it does the expensive stuff on the element. Basically, we're passing 1, 2, 3 here for the function parameter, and then it logs the result. Okay, at the end we have a main function. Nothing. It just that it just logs starting job, ending job. In between, it calls the function loop for each. Straightforward. Okay, so I want you to guys to pause the video and try to analyze the code, try to see what are the order in which we get these console logs. Okay, so pause the video and come up with this. Either take a pen and paper or try to execute the code yourself. Okay, let's see how many of you guys get it right. Okay, let's run this code. So I'm going to say node 1, enter. So there we go, we're getting the logs. All right, the code is then executing. So here, if you can see, we are initially getting starting job. Okay, and then we see starting expensive stuff 1, 2, 3, and then ending the job, and then we see ending expensive stuff 1, result is 2, again similarly stuff 2, result is 4, stuff 3, result is 6. A bit of weird behavior here, right? So let's analyze why is this that after ending the job we're getting the results. Okay, we'll analyze that. See, the first thing is here loop for each is synchronous, right? So this is not asynchronous code, it's a synchronous function, meaning that it's going to execute immediately. It's a synchronous code. So even the main is synchronous. So what happens is when you run main function, we first touch the console log starting job, which is straightforward. So we log that. Okay, and then for loop for each function executes. Okay, since it's synchronous, it actually works inside this for each loop where we have expensive stuff 1. So here we console log starting expensive stuff 1. Okay, because the first value is 1 here, right? We console log that. And then we encounter sleep for 2 seconds, basically an asynchronous task. And this task is not going to be completed for the next 2 seconds, correct? And remember the event loop. So what it does, it starts the task, put it aside, and then come back later, right? So now what's going to happen is all these three logic are put aside, and it will be waiting for 2 seconds. After this is done executing, these things will be executed. Okay, so these things will be put aside right now. And since this is not completely executed, okay, all these things are also put aside right now, because of course this has to be complete, this has to execute before this code is executed, right? Because it depends on that, correct? We walk into the next iteration. Okay, what is the next iteration? 2. Okay, again we log starting expenses stuff 2, and all these things are put aside again because we have an asynchronous task for 2 seconds. And then next iteration 3, expenses stuff 3, we wait for the entire thing. Okay, and now since there is no iterations pending, okay, this for each loop will be marked as completed, and then we go to the next statement, that is ending job. Okay, so we log ending job, the function is done executing. Okay, now the function is done executing, the function is done. Okay, the event loop will realize that, okay, we have an asynchronous task pending which is about to finish. Okay, then the sleep function will complete its 2 seconds of sleep. Okay, and then it will resolve itself. It says I'm done executing for 2 seconds. Okay, and then what we'll do is we'll do the multiplication, then we'll log expenses stuff 1. Okay, and then we return the result. And since this function is complete now, we touch the next statement, that is logging the result. And similarly, the next sleep function says it's resolved. Okay, we do the multiplication, we log the value. Same thing happens with all three. That's the reason we see the starting expenses of 1, 2, 3, ending the job, and then we see ending the result. Okay, that's how it works in case of for each, because for each is synchronous. It doesn't wait for your await or async task to be completed. Okay, if it was, so let's say this is asynchronous, it waits for asynchronous task. What happens then? If it was waiting for a asynchronous task, what it does is it will wait until the first iteration is completely done. Meaning that it will wait for 2 seconds where you execute all this and return the result. Only then it will go to the next iteration, that is 2. Okay, since this is not asynchronous, it is synchronous. It's not going to wait until everything is done. If the first iteration is just put aside, it will assume that it's done. It will move to the next one. Okay, that's the difference when you're using asynchronous implementation with for each. Okay, it won't wait. Okay, rather it will let it resolve itself in the background. Okay, now moving on to snippet number 2. Let's jump into snippet number 2 here. Okay, here we have the same code, okay, as snippet number 1. The only difference is here we're using for each loop, but here we're using for loop. That's the difference. And I'm marking this as async because here we are using async function inside for each, but in case of here we cannot use that. So that's the reason we're marking the whole function as async. Okay, and also remember, I'm not awaiting it here. Okay, just for the trickiest part. Okay, all right, now again pause the video, try to come up with the answer. All right, I'm gonna run the node snippet number 2. If I do that, you can see the behavior is slightly different, correct? All right, now let's analyze this. Initially we say starting job, straightforward. Okay, and then we go inside the function here. When we go inside the function, again remember, I'm not awaiting this. Okay, very important to remember, I'm not awaiting this because this matters. Okay, so I'm going inside for loop here. Okay, we run the loop, const d of data. Okay, 1, 2, 3. Okay, d will be 1, 2, 3. Okay, depending on the iteration. So here we jump into do expenses stuff here. Okay, we log starting expenses stuff 1. We log that. Okay, and then we encounter await sleep for 2 seconds, asynchronous task. So this whole thing is put aside. And since this is not completely executed, even this is put aside by the event loop. Okay, and now for loop is actually asynchronous. It waits for asynchronous task to complete. Okay, since it's gonna wait, it is not going to move to the second element here because it realizes that these four things are yet to be completed for the first iteration. Okay, that's the reason it's gonna wait. And since it's waiting, since we don't have an await here, if you add an await, okay, let's say you add an await here, await, await. Okay, if this was the case, you wouldn't see ending job here. You will see the ending job at the end because now even for loop is actually waiting for the entire thing to complete. Since you don't have an await here, this will be considered as synchronous function and you will see ending job here. Okay, and after 2 seconds, when this is resolved, we can see the result, okay, of the multiplication. This ending stuff is printed, that is ending stuff 1, result is 2. Okay, and now since ending job is already done, okay, we go to the next iteration. Since for loop was actually waiting for the first one to complete, and now when we see result is 2, the first iteration is complete. Now it goes to second iteration where we actually go there, we log the starting expenses stuff 2, we wait until this 2 seconds is completed, and then we do the multiplication, we log the expenses stuff 2, and then we log the result, and then we go to the third iteration, and so on. Okay, got the difference? For each doesn't wait. That's the reason we see starting, and then ending. But for loop actually waits. Okay, so that's the reason you see until everything related to number 1 here, the first item is completed, it doesn't move to second one. Okay, cool. And again, if you add an await here, you would see that the result would be different again. If you add an await, async and await here, the ending job would be at the end here after result 6, not before that. Okay, Cool. That's the trickiest part. You just remove await await from somewhere, and you see the whole thing is different. That's the reason it's a nightmare to work with asynchronous JavaScript. You just don't realize how a single word or a single thing that you remove or add somewhere will make a huge difference in the resulting output. Okay. All right. Moving on to snippet number 3. There we go. A slightly different, but actually similar to the first one. You can see for each. Even the first one we used for each. But the only difference is we are actually sleeping after the result one, okay, and actually calling the function again. That's the difference. Okay. So here you would call the expensive stuff just once, but here you're calling it twice, and you have a delay in between. Okay. Pause the video and let's see how many of you can get this right. So I'm gonna just run the function, node 3. There we go. And if you guessed it like this is nothing but a clone of first one but twice, you're actually right. Okay, but you have to understand why is that. Okay, let's see. So first thing is we'll actually console log starting job here. Okay, straightforward, of course. Okay, and then we go inside double loop here. We go inside for each. We log do expensive stuff, which says starting expensive stuff 1. Okay, and then we have sleep. So we put all these things aside. Okay, and since all this is not completed yet. Okay, for each being synchronous, it's going to move on to the next iteration. That is 2. We log 2. Okay, and we put all these things aside since it's an asynchronous task here. Then we move on to number 3. Okay, then we put all these things aside, and since these things are still pending, okay, I mean these things are put aside, for each will mark all since it has reached 3 already. Okay, and there is no element available, it's going to say hey, I'm done executing. So this will be done executing, double loop is done executing. Now we see ending job. Okay, now what happens is we see endings expenses stuff 1. Now this 2 seconds is done. We're going to multiply this. We're going to say ending expenses stuff 1, return the result. This is completed and executing. Now we see the result of 1 is 2. Okay, and then we have sleep again, right? So these two logic will be put aside again because we have a sleep function. Okay, and then we wait for after another 2 seconds, the second iteration is completed. So we see console log result is 4, result is 6. Okay, and by the time the result is 6, these first 2 seconds is completed here. So we run this function again. So when we run this function again, what happens is we console log expensive stuff 2 because we're passing this result, right? So once this is completed, right, we see result is 2 here. Okay, and then we sleep. When we sleep, right, since we're using let here, the scope is actually isolated. So it doesn't share the global scope, it shares the local scope. So it is isolated. If you use var here, it will be different. Since you're using let here, it will be isolated. That's the reason you see 2. Okay, and then what happens is since we encounter sleep again, we put this aside. Okay, that's the reason you see starting expensive stuff 2, 4, 6. The reason is we're encountering the sleep again. And why are we getting 2, 4, 6, not 6 here, since the end result was 6? Because you're using let, not var. If you use var, you would see expensive stuff 6, 6, 6, not 2, 4, 6. Okay, and then after 2 seconds, of course, this will be done resolved, and we multiply it, and then we log the result. That's the thing. Okay, you got an idea now. Even moving a single await or elsewhere or adding async somewhere, the whole flow differs. And also you have to keep your idea on what type of scoping you're dealing with. Okay, are you using let where we have a lexical scope or local scope? Are you using var where we have global scope? This also matters when you're dealing with asynchronous task a lot. Okay, so this was it, guys. 3 files, 3 different or similar implementation, but 3 different behaviors. Okay, that's how the asynchronous JavaScript works. A bit tricky, but if you just understand the basis of it, the foundation of it, and if you just spend like 10 minutes just going through the code, how it works and everything, you'll be able to figure it out. Also, there is one more thing. You can see we are multiplying string with a number, right? And one of the thing in JavaScript is that if you add string with a number, it's going to become string. But if you multiply a string with a number, it's going to become number. That's also important. That's the reason initially I said it's a number. Sorry, it's a string, not a number. Okay, you have to understand that as well. All right, with that said, that's it for today, guys. And don't forget to subscribe, and do not forget to join our community, WhatsApp or Discord. We have both. You can join anywhere you want. Okay, and keep sharing this with your friends, and we'll come up with some more trickiest JavaScript interview questions regularly. Okay, see you next time. Bye.